In this video, we're going to learn how to find the period of a sinusoidal function. First, we have to understand what period means. Take note that a function can be periodic or non-periodic, and that a function can be tested whether it's periodic or not. If a function, however, is periodic, it means that it will have the same curves repeated in an interval. Now, let's illustrate it to understand more about period. Think of a period as where the graph completes one cycle. Consider this function right here. Is this periodic or not? Since there's a pattern that keeps repeating, then this is periodic. And we can see that the pattern is a triangle. Now, how many steps does this graph complete? One whole shape and repeats that shape for the next intervals. We're going to count where does the shape stops and repeats itself for the next intervals. Since our graph increases from 0 to some height and then back to 0 in an interval from 0 to 1, then we have a period of 1. Then what about our next function? We can see that this function completes one cycle from 0 to 2 and repeats itself from 2 to 4 and the next intervals. Then we have our period as 2. For our third function, shape repeats itself after 3 steps. This is our shape right here. Therefore, our period is 3. Now, consider the graph of a sine function. To see more details in graphing the sine function, you can watch my other videos for plotting the trigonometric functions, since we're not gonna tackle much more about that in this video. Now, let's go back to our function. This is the graph of a sine function, y is equal to sin x. Now, how do we find the period of this function? Since period is determined by how many steps the graph takes to complete one cycle, and we have our one whole cycle completed from 0 to 2 pi, and then repeats that cycle for the next intervals, then our period is 2 pi. Now, how about our sine function? Let's redraw our y is equal to sin x, and we're going to compare that two other functions together with y is equal to sine 2x and y is equal to sine 3x. And note that y is equal to sine x completes one whole cycle from 0 to 2 pi. We're going to draw one cycle from 0 to 2 pi. Now let's consider y is equal to sine 2x. See that this function looks similar to y is equal to sin x but has the number 2 before the letter x. We'll define this as the number of cycles created from 0 to 2 pi. Since we have the number 2 before x, then we'll make 2 cycles from 0 to 2 pi. The same thing goes with y is equal to sine 3x. Since we have 3 before x, then we have 3 cycles from 0 to 2 pi. 1, 2, 3. That goes also the same with y is equal to sine 4x, y is equal to sine 5x, and so on, and that applies to any sine function. Now, we've determined the number of cycles for several functions, but how do we find the period of those? Take note that if we have one cycle completed from 0 to 2 pi for our graph y is equal to sin x, then our period is 2 pi. We're going to circle that. If we have 2 cycles, then for y is equal to sine 2x from 0 to 2 pi, then the period must be half of 2 pi. 2 pi over 2 is pi. The same thing goes with y is equal to sine 3x. We have 3 cycles, then the period must be 1/3 of 2 pi, or 2 pi over 3. Now, let's do more examples to fully understand period. Consider the function y is equal to sine 5x. What is its period? Since the period is 2 pi over the number before x, and the number before x is 5, then our period is 2 pi over 5. Now, for another example, y is equal to sine pi x plus 2. The period is 2 pi over pi, which is 2. Take note that we have to look for the number before our x, and that is pi in this case. Now, this looks confusing because we've added the number 2 in our function. However, the number 2 in that function is the vertical shift, and it has nothing to do with our period. Now, what if for the function y is equal to sine 2 sine ex? What is our period? Since the number before x is e, we have our period as 2 pi over e. See that the period was not affected by the number 2 before the sine, since that only affects our amplitude, and amplitudes, phase shift, and vertical shifts will be tackled in different videos. Therefore, to generalize the period of any sine function given the standard form of a sinusoidal function, y is equal to 8 sine bx plus c plus d is 2 pi over the number before x, letter b. For a, c, and d, the meaning of those values will be discussed in my other videos.